Hello and welcome to Honors Function. In this last lecture on the algebra of functions, I'm just going to go over some examples of function compositions. Okay? So let's start with example number 1. So example number 1 looks like an example we have done already in the previous lecture, but this time I'm asking you for g of f and the domain of g of f. Yesterday it was f of g. Okay, so let's go with g of f. So g of f of x is by definition g of f of x, and so let me plug f of x inside g. So it is a square root of 4 over x squared minus 1 plus 3, right? So let's add these. There are two fractions, I need to add them. So I have 4 plus 3 times x squared minus 1 over x squared minus 1. And so it is square root of 3x squared minus, right here I would have a minus 3 plus 4 is plus 1, 3x squared plus 1 over x squared minus 1. Okay? So this is g of f, the rule of assignment for g of f. Now let's look at the domain of g of f. Well, you know there are two conditions. First, you have to be in the domain of f, and you got to make sure that g of f of x is defined. Okay? So, when are you in the domain of f? Let's look at the domain of f. Well, that's pretty simple. You don't want to make this equal to 0, x squared minus 1, and so it's all real number except negative 1 or plus 1. Okay, I didn't use interval notation for this. Now let's understand the other condition. When is this defined? Now this is going to be a little bit more interesting. So g of f of x is equal to the square root of 3x squared plus 1 over x squared minus 1. So when is this defined? When what's inside is positive or equal to 0 and x squared minus 1 is not 0. Now let's look at what's inside right here. So I'm looking at this inequality. 3x squared plus 1 over x squared minus 1 positive or equal to 0. This is actually pretty simple. It doesn't look like it maybe, but it's actually pretty simple to solve. And I would like you to see these kind of things. Look at the numerator. If you look at the numerator, it's 3x squared plus 1. Okay? So 3x squared plus 1. What is the lowest value of 3x squared? 0, right? The lowest value of x squared, lowest value. The lowest value of x squared is 0, so if you multiply by 3, it's 0. So the lowest value of 3x squared plus 1 is going to be 0 plus 1, which is 1. Another way of saying that is, if you look at the parabola 3x squared plus 1, the vertex is at 0, 1, so 0, 1 right here, and the parabola is concave up. So basically, it's always positive. The parabola is always positive. It's never equal to 0. That's what I'm saying right here. 3x squared plus 1 is always above or equal to 1. So 3x squared plus 1 over x squared minus 1 will be positive when x squared minus 1 is positive, right? Because the top is always positive. So if the denominator is positive, then the ratio is positive. If the denominator is negative, then the ratio is negative. Okay? So when is this positive? Well, that's pretty straightforward. When x is between negative infinity and negative 1, or negative 1, 1 infinity, right? This should be pretty clear, right? It's an old type of problem. Parabola is concave up, x-intercepts are negative 1 and plus 1, positive outside the roots, all right? Okay, all right, now let's not forget that x squared minus 1 cannot be 0, therefore these parentheses, these brackets, are going to be replaced by parentheses, right? Because x cannot be plus or minus 1. So the domain right here for g of f of x is in negative infinity, negative 1, union 1, infinity. Now let's see what we had for the domain of f. The domain of f was all real number except negative 1 and 1. Negative 1 and 1 are not in here. Therefore, the domain of g of f, the domain of g of f is negative infinity, negative 1, parenthesis, union 1, infinity. Okay? For this, it's the same as the domain of the expression of g of f. Adding the domain of f does not add any new condition to it. Okay? All right. That's it for the first example. Let's go over example number 3. Okay, so here we're taking 3 functions inside each other. So first h, then g. So what is g going to do to h? So g of h of x is going to be g is squared minus 1, right? So it's going to be h of x is going to square it, x plus 1 squared minus 1. So it's 1 over x plus 1 minus 1. So common denominator right here, right? So it's 1 minus x minus 1. Be careful with this negative sign, over x plus 1. So it is negative x over x plus 1. All right. And now what do you do to that? You add 1. Actually, I should have left it there, right? Because if now you take this and you put it inside f, what does f do? F adds 1 to whatever. So right now the whatever is this. If you add 1, you're just going to find 1 over x plus 1, okay? Which it would be the same if you were to take this and add 1, but actually it's better not to do the algebra in this case, okay? You don't always see that at first. I'll let you do number 4. Let me do number 5. All right, let's do f of g of x. So f of g of x, so you take g of x right here, which is x squared minus 1. And what do you do to it? You add 1. That's what f does. F just adds 1, right? So it is just x squared. And then this is thrown into h. So it's h of f of g of x right here. So if you throw that into h, you have 1 over square root of x squared plus 1. That's it. Okay, and you cannot simplify this. Okay, now let's do number 7. So let's get g of f of x first. So g of f of x. So what does g do? G squares and subtract 1. So you're going to take f of x right here. You're going to square that and you're going to subtract 1 to it. Okay, so this time let me not expand it because I'm looking at the next one and I know something is going to simplify, right? Now let's throw that into h. H of g of f of x. So what is this? So you have 1 over the square root of, and so this right here plus 1, right? So x plus 1 squared minus 1. Okay, this is g of f of x plus 1. So this is just 1 over the square root of x plus 1 squared. And here, guys, who is going to remember this? Okay, this is 1 over x plus 1, not absolute value of x plus 1, right? Okay, you got to remember that the square root of a squared is the absolute value of a. It's a formula we've seen somewhere in the first unit. All right? Okay, let's go over number 9 now. So in number 9, you have to write this function as the composite of 2 functions, but they cannot be the identity. Okay? So there are so many ways to do that. So what I want to do right here, for example, the 2 functions, I'm going to call them h and g. Okay, so let's say h of g. G is called the inside function, especially in calculus, and h is called the outside function. Okay, what you cannot do right here would be to say that g of x is square root of 2x minus 1 and h of x equals x, right? If you combine these two, what are you going to have? You take g, if you do h of g of x, what do you have? You take g and you throw it into h, right? So it is equal to square root of 2x minus 1, which is f of x. But this is called the identity function, function, and I don't want you to use the identity function, so this is not an acceptable combination. So what are you going to do then? Well, it's not that difficult. Here's a possibility. So which one is the outside again? H is the outside. So for h, I could take, for example, square root of x minus 1, and for g, I could take, for example, 2x, right? What happens if you do h of g of x? Well, you're going to get g of x thrown into h, right? So it's square root of 2x minus 1. And this is f of x. So that's it. You have found two functions right here, okay? H and g. But this is actually not even the easiest possibility. I think the easiest possibility would be to say that the outside is the last thing that happens to the function. So the first thing that happens to the input would be the linear thing, 2x minus 1. And the second thing would be the root of it, okay? And so if you do h of g of x, again, you're going to find the square root of, and here 2x minus 1, okay? You take that and you plug it inside. Okay, I'm gonna stop here this very short video just of examples. I hope things are getting clear about composition and especially their domain. Thank you for watching.